Okay, so remember this loop problem that we did? जिसमें there was a toy car. The toy car comes in with the speed of v naught, right? And then it goes around this loop, then it exits the loop, and you have to find out the speed v naught such that it's able to remain in contact with the track, with the track that comprises the loop. Okay. And how did we do that? कैसे निकाला था? आपने ऑफ कोर्स देखा ही नहीं क्योंकि ये कंजर्वेशन ऑफ एनर्जी अपैरेंटली हो गया था. आपका न्यूटन्स लॉज पे कुछ था और कैसे आपने देखा ही नहीं. Okay. Yeah, but you essentially had to look at F is equal to ma essentially. Okay. So at the top, आपकी फोर्सेस जो लग रही हैं इस टॉय कार पे, दे आर द नॉर्मल फोर्स एंड mg. Right, so the net force towards the center of the circular path must be equal to नहीं mv square, because this thing is moving in a circle. This toy car is moving in a circle. It will be equal to mass times the radial acceleration. The net force towards the center of your circular path must be equal to the mass times the acceleration towards the center of your circular path. Okay, this however we show that the radial acceleration, the acceleration towards the center of your circular path equals v square over r. We showed that for uniform circular motion. Is this uniform circular motion? How do you know that this is uniform circular motion? Or how do you know that this is not uniform circular motion? नहीं, uniform circular motion has nothing to do with कि radius constant रहता है या नहीं रहता. अगर circular motion है, that means कि radius constant रहता है. Otherwise, it's not moving in a circle. It's moving in some kind of weird spiral. Okay, this is moving in a circle, so this is circular motion. Whether it's uniform or non-uniform refers to something else. यूनिफॉर्म circular motion में उसकी ऑब्जेक्ट की स्पीड कांस्टेंट होती है, नॉन यूनिफॉर्म में उसकी स्पीड चेंज होती जाती है. यूनिफॉर्म में the angle that it sweeps out, the rate at which the object sweeps out is constant. For non-uniform circular motion, the rate at which the angle is swept out is different. The angle at which this angle is swept out. Okay. इधर non-uniform circular motion है, इधर नीचे आपकी गाड़ी ज़्यादा तेज है, जैसे जैसे ऊपर जा रही है slow down हो रही है. This is non-uniform circular motion. So then how can I conclude that the radial acceleration is still v square over r? Well, I can conclude it if I live under the illusion that you actually bother to solve a problem in the readings dealing with non-uniform circular motion, जिसमें show किया गया है कि even if you are dealing with non-uniform circular motion, then you will have radial acceleration, you will have a tangential acceleration there as well, because you need a tangential acceleration to speed up or slow down the object. But the radial acceleration is still given by v square over r, जहाँ v is the speed of the object at the point at which you are calculating the radial acceleration. Okay, so this is still equal to mv square over r, where v is the speed of the object at the top. And then from here you say that okay, n is equal to mv square over r minus mg. So the object is able to remain in contact when the normal force equals 0. Because if the normal force becomes negative, then the object loses contact. Okay, it just falls down. If the normal force is positive, it remains in contact. Why is that true? Because the normal force pointing downward implies that the track is pushing back on the toy car. If the normal force becomes negative, then that means कि ये ऊपर की तरफ push ही नहीं कर रहा है track को. Okay, the normal force then is upward on the toy car, which means that on the track the force is downwards. This toy car is pulling this track, which is physically impossible. As long as the force acting on the toy car is pointing downwards, which means कि इधर sign n का positive है, the toy car is pushing up on the track, and so it remains in contact. Okay. And therefore, it is just able to do this when the normal force is equal to 0. If it becomes negative, it loses contact. If it's positive, it remains in contact. Then you have v square over r equals mg, and therefore you need the speed at the top to be equal to g times r. M and m cancels. And then you use conservation of energy to figure out कि इधर क्या speed हो इसकी, such के इधर speed उसकी, इधर speed squared उसकी g times capital RO. And we figured that out that in class we found that this speed should be equal to square root of 5gr. In other words, another way to understand this is कि अगर इधर रुकी हुई है आपकी toy car, तो of course वो गिर जाएगी. Just like if the moon suddenly came to a stop, it would fall towards the earth. Moon क्यों नहीं करता? Because it is moving. So the acceleration goes into changing the direction of your velocity vector. Exactly the same way over here, if the toy car is moving at the top, then perhaps it doesn't fall down. But of course, there is a critical value. अगर 0 पे fall down करती है तो 10 raised to power minus 6 meters per second पे भी probably fall down करेगी. Okay, there will be a limiting positive value of velocity such that below that speed it falls down, above that speed it doesn't fall down. Okay, and that's exactly what you have over here. Then you can use conservation of energy to figure okay, at least इतनी होगी speed bottom पे ताकि top पे इतनी speed बन जाए. Now I change the question. कहता ठीक है okay, you know. अगर suppose करो तो उसकी speed जिस speed पे वो enter होती है वो ये है. अब मुझे पता है कि गिर जाएगी. But the question now becomes कि किधर गिरेगी? At which point will it lose contact with the track? My another variant of this question would be कि मैं कहता हूँ कि you know कि the toy car never becomes even partially upside down. What is the value of V naught then? That means कि इस point को cross ही नहीं करेगी toy car. क्योंकि जैसे ही इस point को cross करेगी it becomes at least partially upside down. तो क्या मतलब इस point पे आके रुक जाए आपकी toy car और फिर वापस of course नीचे आ जाएगी. तो कितनी V naught होगी सच की इधर आके रुक जाए? Well, that's just simple conservation of energy. Initially उसकी kinetic energy है सिर्फ half m V naught square. I'm setting potential GP 0 over here. इधर उसकी सारी वही kinetic energy आपकी gravitation potential energy बन जाए, which is mgr. So you straight away have that half m V naught square should be equal to mgr, right? And you have your V naught that you need. लेकिन now I'm saying कि भाई इतनी V naught से आई है toy car किधर जाके contact lose करेगी? So to quantify कि किधर contact lose करती है, let me quantify that in terms of some angle theta. इधर toy car of course आपकी यूं है. What's so special about this value of theta at which it loses contact? In terms of forces, the normal force is 0 at the point at which it loses contact. Because when n is 0, that means it's on the verge of losing contact. थोड़ी सी उसके फौरन बाद it loses contact. So we have to figure out the normal force at this point. So you first of all draw the, if nothing else, write the number लेने के लिए at least draw the free body diagram of this toy car. तो एक normal force यूं नीचे होगी और weight नीचे होगा और क्या होगी? Normal force यूं करके होगी या यूं करके होगी? Why radially inward? मैं उल्लू हूँ, मैं खोता हूँ, मुझे कुछ नहीं पता, कन्विंस मी के अंदर की तरफ है हो गया. क्या कहोगे? Because the toy car is going to push the surface in that direction and therefore the surface pushes in the opposite direction on the toy car. You have that. Another way to argue this is कि भाई आप opposite assume कर लो. Assume करके normal force इस direction में लग रही है on the toy car. Then on the surface the normal force is acting like that on the surface. But that means that the toy car is pulling the surface. But that's impossible. You can push a surface, but you cannot pull this. Okay? आप बुनियान वगैरह पहनो, जिम जितना मर्जी जाओ, ये काम नहीं कर सकते आप. You cannot pull a surface. You can only push surfaces. Okay? So the normal force must be in that direction. And now I have to apply Newton's second law. So this is circular motion. You know the acceleration towards the center of your circular path. So you know the acceleration towards the center of your circular path. So just to simplify the application of Newton's second law, choose one of your axes in the radial direction. क्योंकि आपकी radial acceleration का वही direction होगा जिस direction में आपने axis set किया. Then the other axis of course is in the tangential direction. So you set one of your axes to be in the same direction as the radial direction. The other axis is then perpendicular to that. So suppose को मैं कहता हूँ ये मेरे एक axis है, ये मेरी दूसरी axis है. In the radial direction, what do I do and write? With these axes, क्या मैं लिखूँगा? You'll be writing minus n, क्योंकि n is radially inward. You have chosen the radially outward direction as positive. आपका unit vector is pointing radially outward. और कौन सी radially inward force है? mg cos theta. अगर ये थीटा है तो ये भी थीटा है. Okay, this line and this line are parallel lines. There's a line intersecting them. So there's something called alternate angles. 2000 years ago. Okay. So you get basically that this is minus mg cos theta. This is the net force towards the center, or you'll write that this is then equal to mass times acceleration, which in this case is the radial acceleration, which is equal to mv square over r. Now two things. This is the centripetal, what we say is the centripetal force. Centripetal force itself is not a force. It's just ma. So if I say y is something able to move in a circle, don't say centripetal force, okay? Every nincompoop knows that there must be a force acting towards the center in order to make that object move in a circle. The important thing is, I'm actually asking is that bhai, ye force towards the center aa kidhar se rahi hai? Which physical mechanism is responsible for producing this force? If it's a car that you are turning on a road, it's probably the friction force acting on your tires. If your car is turning on a banked road, then it's a component of the normal force that is providing the centripetal force. If you are running in a circular track, it's again friction force that is responsible for your centripetal force, and so on and so forth. Okay. For the moon, it's the gravitational force that's responsible for the centripetal force. Okay. For the hydrogen atom, if you treat it classically, it's the electrostatic force that's responsible for the centripetal force, and so on and so forth. Okay. इसमें गलती है. क्या गलती है? I mean, mathematically गलती है. The left hand side is negative, the right hand side is guaranteed to be positive. Astaghfirullah. तो क्या गलती क्या है? Yeah, the acceleration is radially inward. V square over r is simply the magnitude of your acceleration. उसका direction भी तो account में लेना है. F is equal to ma is a vector equation. ये minus mv square over r. You could have, of course, chosen the radially inward direction as positive. As in, आप unit vector जो है radial direction में inward के बता सकते. Then you just straight away be writing down as n plus mg cos theta is equal to mv square over r, which is of course exactly the same as that. Okay. So, in other words, you have n plus mg cos theta is equal to mv square over r. Okay, so the normal force becomes equal to mv square over r minus mg cos theta. And at the point at which it loses contact, this must be equal to 0. And therefore, mg cos theta equals mv square over r. M and m cancels simply because usually whenever you have gravity involved, the force of gravity is proportional to the mass, and the effect of gravity is also proportional to the mass, so that's why m cancels out. ma में भी वही m है और mg में भी वही m है. So you have that cos theta is equal to v square over gr. That's not enough. If I say derive an expression for theta, ये आपको इधर तक अभी ये तक आधे नंबर मिलेंगे, because when I say derive an expression for something, what is meant implicitly is that you have to get an expression such कि मैं उसमें straight away numbers को डालूंगा and I'll get the answer. You know G, you know capital R. Sure. But you know V. V क्या? V is the speed of this toy car at the point where it loses contact. वो तो आपको नहीं पता. You still have to figure out V. You have to figure out V in terms of theta. You need to figure out the value of V at the value of theta at which it loses contact. अच्छा, तो अब कहते हो वेल v मुझे पता तो है सर जी, v नॉट पता है मुझे. डिस्टेंस जो ये मूव करता है, ये अगर ये थीटा है तो ये पाई माइनस थीटा देखें, इसने एंगल कवर किया है. रेडियस r है तो दिस आर्क लेंथ इज r टाइम्स पाई माइनस थीटा, तो v स्क्वायर इज इक्वल टू v नॉट स्क्वायर प्लस 2 टाइम्स एक्सेलरेशन टाइम्स आर्क लेंथ. व्हाई इज दिस अ कंप्लीट लोड ऑफ क्रैप? ओके, क्यों नहीं कर सकते? v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2as. The acceleration is not constant. Why is the speed of this toy car changing? Because of the component of the gravity, tangential component of gravity. आपके gravity का tangential component g sin theta, जो mg sin theta है, अभी तक उसको तो मैंने देखा ही नहीं था. I was just looking at the radial component of gravity. The tangential component of gravity, देखो mg sin theta जो आएगा, that is responsible for the tangential acceleration. वही तो इसको slow down कर रहा है. ये ऊपर जा रहा है और आपकी gravity का component यूं लग रहा है. That's exactly what is slowing it down. और वो change होता जा रहा है. It depends on theta. As the toy car moves, theta changes, and so the component of the force in the tangential direction keeps on changing. So the tangential acceleration keeps on changing. So you're dealing with a problem in which the force as a function of theta, the force that is responsible for changing the speed of the object. If you have a problem in which force, the dependence of force, the effective force, either the force or speed change करेगी वो mg sin theta. Total force of course constant ही है. The total gravitational force is mg, that is constant throughout. But the component of the force that is causing the acceleration, कोई normal force भी तो है ना साथ. The component of the force that is responsible for the acceleration, that keeps on changing. And if you're dealing with the force that keeps on changing in position, that is a problem ripe for attack using work and energy. Okay, so if you know the speed over here, you can figure out the speed over here. Of course, if you have masochists, you'll say, it's time for me to shine, okay? Let me do this by integrating the force of gravity along this curved path, okay? I know how to do that, okay? You don't need to do that because gravity is a conservative force. You can calculate the work done by gravity in a much simpler way, okay? But let's use the work kinetic energy theorem. You know the kinetic energy of the toy car over here. You have the kinetic energy of the toy car over here. That's half mv square. So the change in kinetic energy of the toy car is simply final kinetic energy minus initial kinetic energy. This is equal to, like, अब V0 आया. अभी तक V0 तो आया ही नहीं था. V0, remember, was once upon a time has had its square root of 4gr. Okay, I've thrown in the toy car with a speed less than what is required for it to complete the loop. Okay, and this is equal to the work done by gravity. The work done by gravity, I can consider कि toy car को instead of इस path के लेके जाने के मैं vertically ऊपर लेके जाता हूँ फिर यूं लेके जाता हूँ. यूं लेके जाने में कितना work करेगी gravity? Zero, because gravity is downward, horizontal. इतना करने में कितना करेगा? Well, mg is pointing downwards, constant. The toy car is moving vertically upwards, so the work done by gravity will be negative minus mg times this distance. This distance equals this distance, which is r, plus this distance, which is r cos theta. ये r है, ये theta है, so this is r cos theta. So the total vertical distance is r plus r cos theta, and therefore you'll get minus mg times r. r को factor out कर लेता हूँ, r plus cos theta. On the left hand side, you have a negative number. V, remember, छोटा है compared to V0. On the right hand side, you also have a negative number. Okay, again, keep on doing these checks, okay, these straightforward checks along the way. m throughout मैं cancel कर देता हूँ, of course, as usual. Half से मैं multiply कर देता हूँ, तो ये गया, इधर ये गया, इधर 2 आ गया. अब V square is equal to V0 square, but V0 square is 4gr. So I get 4gr minus 2gr 1 plus cos theta. And this is equal to 4gr minus 2gr minus 2gr cos theta, which is equal to 2gr minus 2gr cos theta. देखो. This is the वो मैंने क्वेश्चन में दिया था ना, that this is the speed at which I throw in the toy car. If it was given to you कि ये 4.5 g आ रहा है तो square root of 4.5 g आ रहा है, बेटा 4.5 g लिख देते हैं. That depends from that's basically just the speed at which you threw in the toy car. Okay, and from there you get cos theta. This is the theta at which it loses contact. The speed at the angle at which it loses contact is equal to that, where theta is the angle at which it loses contact. So this is then equal to v square, which is 2gr 1 minus cos theta divided by gr. And you know कि ये dimensional ऐसे आना चाहिए right hand side पे. Curly brown hair है. Cosine of an angle is the ratio of two lengths, which is dimensionless. So gr कट जाता है. which is equal to 2 minus 2 cos theta. So cos theta is equal to 2 minus 2 cos theta, and even you can solve this one now. So, we have 3 cos theta is equal to 2, and therefore cos theta is equal to not 0, 2 by 3. Okay? And therefore, so what does this tell you? कि अगर आप मून पर जाके ये काम करो, where does the toy car lose contact? At exactly the same point. Your answer is independent of G. If you use the bigger track, if you use a track with bigger value of R, where does it lose contact? Exactly the same angle. The angle is independent of capital R. That's the beauty of doing things in terms of algebra, in terms of these symbols, ताकि आपको clearly पता चलता है कि आपका आंसर किस चीज पे डिपेंड करता है, किस चीज पे नहीं डिपेंड करता. शुरू में इधर नंबर्स डाल के बैठ जाओगे, अल्लाह जाने किस चीज पे डिपेंड कर रहा है, किस पे नहीं डिपेंड कर रहा. ओके, फिर वही आपका अल्लाह स्ट्रेटजी ऑफ डूइंग फिजिक्स पे आ जाओगे. ओके ओके, सारी फिजिक्स आपकी अल्लाह स्ट्रेटजी होती है. आंखें बंद करके फॉर्मूले में कुछ डाल दो कि अल्लाह करे शायद कोई आंसर आ जाए. बट एवर नंबर कम्स आउट, इट कुड बी अ फोर्स, इट कुड बी एन एक्सप्रेशन, अल्लाह करे सही आया. ओके.